So, before anything else, the two voices explaining AI to you, well, they are themselves AI.
Yeah, which is, either poetic or ironic. We have not decided.
Right. The research and the writing are dastans. The voices are us.
Exactly. Machine voices, human mind.
Welcome to Plain Strata, where we take decentralized AI apart one layer at a time.
Glad to be here.
Yeah, we are really getting into it today. This is a layer. Today is all about authorization. How a single yes from a person transforms into a permission that a total stranger can verify days later.
Right.
So picture this. Paint the scene in your head. It is a Tuesday evening, right, platoon. You are sitting on your couch, maybe watching TV, and you open up your banking app. You tap a button that says approve.
Just a normal Tuesday.
Exactly, just a normal Tuesday. And you are setting up this approval for groceries only. You set a capped amount, let us say, I do not know, 80 or $100, and you give it a window of 7 days.
Mm-hmm.
Then, you put the phone down, you go to sleep, and you just completely forget about it.
Right, the human part is totally done.
Totally done. But then, fast forward, it is Friday at 3 in the morning. You are fast asleep. And while you're sleeping, a piece of software buys $87 of groceries in your name.
While you are completely unconscious?
Yes, exactly. And nobody calls you to check. The software does not buzz you to ask for a code.
Yeah.
The grocery store does not call your bank. It just happens.
And this brings us right to the spine of this entire episode. Yeah. Because everything we're going to talk about lives in that gap between Tuesday evening and Friday morning.
Yeah.
I want to lay this out really clearly, right up front. Before anyone can check whether software did a job correctly, someone has to have said it was allowed to try.
Right.
And that permission, that initial yes from Tuesday, is now its own signed, bounded, checkable object.
A checkable object. That is the hook here, right? Because that gap between Tuesday and Friday, it just got its own dedicated infrastructure on July 22, 2026.
Finally.
Yeah, exactly. Finally. It closes a massive, and I mean massive, hole in autonomous software. We know what happened on Friday morning, but to really understand why this new infrastructure is such a breakthrough, we have to look at what the software world spent the last 2 years building.
And, well, the massive blind spot they totally missed while they were building it.
Right. So let us transition into that. Let us talk about the missing axis of trust.
Okay. So let us start by defining the actual subject here. We need to talk about what an agent is.
Yeah, because that word gets thrown around a lot.
It does. It gets hyped up. But I want to define agent in its most unromantic, completely literal sense. An agent is just software that makes decisions and acts.
It does not wait for exact instructions.
Exactly. It does not sit there waiting for a human to hit enter. It goes out and does things.
Okay, so when this agent goes out to, say, spend your money, it currently has to answer 3 big questions, right? These are the 3 existing pillars the industry has already built.
Right. These are the ones everybody knows about.
So the first question is, who is this? When the software knocks on a merchant's digital door, the merchant needs to know who is knocking. And this is answered by a standard called ERC 8004.
Right, which is just a durable, registered identifier.
Yeah, because, a regular web address is useless for identity. Scammers can just buy a domain for $3, burn it, and buy another one. So ERC 8004 gives the software a real permanent anchor.
Okay, and once you have that anchor, you get to the second question.
Right. How has it behaved?
Yes. Reputation.
Exactly, reputation. So now that the agent has a permanent name, you can attach its past history to that name. Has it scammed people before? Does it pay on time?
Right, so you have identity and you have reputation.
And then the third pillar is, did it do the work right?
Ah, the verification piece.
Yes. This is all the heavy cryptography we have seen over the last few years, mathematical proofs or hardware attestations from secure enclaves, or just straight up rerunning the computation to prove the agent did not hallucinate the result.
Okay, so those are the 3 pillars. Who is it? How has it behaved? And did it do the math right?
Right.
But notice what is missing there. And this brings us right back to that spine I mentioned earlier. None of those 3 pillars answer authorization.
Wait, yeah, you are totally right. None of them do.
It is the missing 4th pillar. Authorization is a completely different thing.
So, let me see if I have an analogy for this. It is like hiring a contractor with a perfect 5-star reputation, right?
Okay, I am with you.
And they build a flawless, mathematically perfect kitchen in your house. The cabinets are perfectly level, the plumbing is immaculate, but you only hired them to fix a bathroom sink.
Yes, Exactly. That is the perfect way to put it. Correctness and authorization are two entirely different axes.
Yeah.
You can completely fail one while passing the other with flying colors. The kitchen is perfect, but they were not authorized to build it.
Right. They had a great reputation. They did the work correctly, but they had absolutely no permission to do it.
Exactly. So to fix that missing axis, we really need a way to take a human's intention, from that Tuesday evening on the couch and stretch it across time to Friday morning.
Stretch it across time. I like that.
Well, it is literally what the word means. I think to understand this, we should look at what these words actually mean at their roots.
Oh, yeah. Let us do the etymology. I love this part.
Okay, so start with the word intent. It comes from the Latin intender. That is spelled intendere, if you were wondering how it sounds. It literally means to stretch toward.
Wait, really? To stretch toward?
Yeah. It is the mind stretching across time. From Tuesday to Friday, your mind is stretching toward a goal that has not happened yet.
That is incredibly poetic for a software standard.
It is, right. And then we have the word verifiable, which comes from the Latin vers, meaning true. But I want to be really careful here. We are distinctly not talking about a mathematical truth here.
What do you mean? Like 2 + 2 = 4?
Right. The third pillar we talked about, the correctness proofs, those are mathematical truths. But here, with authorization, we are talking about a social fact.
A social fact, like a bank saying, yes, this person actually clicked this button.
Exactly. It is a social fact wearing cryptography. The bank is vouching for a human decision.
Okay, that makes sense. And what about the actual permission slip itself?
Right. The standard calls it a mandate. And mandate comes from the Latin mandare. It is actually two words smashed together. Manus, which means hand, and dare, which means to give.
So to give into a hand.
Exactly. To give into a hand. You are literally handing over a specific bounded permission.
Man, that makes it feel so much more physical. Let us pull this out of the abstract language for a second and talk about that physical reality. What actually exists as bytes when you do this?
Well, it starts with that human action we talked about, just a click in a banking app.
Right.
The user selects merchant category codes. So they pick things like grocery or convenience stores. They set a financial cap, maybe $100, and a time window of 7 days.
And those merchant category codes, those are the exact same ones credit cards have used for decades, right?
Yeah, exactly the same. So after you select those and click approve, the bank issues a public key signed credential.
Okay, so let me stop you there, just so we do not lose anyone.
Huh?
A public key signed credential.
Right.
The bank takes all those rules, the groceries, the money limit, the time window, and they use their secret private key to mathematically lock it, and they sign it.
Yes. And it is locked to exactly those parameters.
Yeah.
And the beauty is, anyone with the bank's public key can check that signature.
They do not even have to call the bank.
Oh, not at all.
Wait, so let me ask you this. Does the person hold this mandate on their phone, like in an Apple Wallet or something?
Oh, no. The person does not hold it. The mandate goes directly to the operator of the agent.
Ah, okay, so the company running the shopping software gets it.
Yes. They hold it in their hand, going back to the root of mandate. And then the agent software carries it to the checkout on Friday morning.
Okay, but this brings up a huge question for me. What exactly is the agent carrying?
What do you mean?
Well, if the bank signed a credential with my rules, does it also have my name, my address, and my account number on it? Because if the agent just hands that over to a random grocery store server at 3 in the morning, that sounds like a privacy nightmare.
Right. And to answer how they fix that, we need to go down to the ocean floor. We need to take a deep dip into the actual mechanism.
I am ready. Let us go down.
Okay, so level 1, the concept itself. The credential is built on a format called SDJWT.
Which stands for Selected Disclosure JSON Web Token, right?
Right.
And in the industry, people just say JOT for JWT.
Exactly. A selective disclosure JOT.
Okay, so level 2, the analogy. Help me picture this. Is it kind of like handing over my passport to a bartender, but they only get to see that I am over 18 and they cannot see my home address or my full name?
Yes, that is the exact analogy. It is a document where certain parts can be revealed while the rest stays completely hidden, but the bartender can still verify the government actually issued it.
Okay, that makes sense.
Yeah.
So let us go to level 3, the absolute ocean floor. What is the actual mechanism making this work in the code?
So the token actually has 3 distinct layers. The first layer is identity. This is who runs the agent and the underlying user relationship. The second layer is the mandate itself, the grocery caps and the time window.
Right.
And the third layer is the specific transaction, the actual purchase happening right now at the grocery store.
Okay, so 3 layers: identity, mandate, transaction.
Right. And selective disclosure structurally prevents the merchant from seeing that first identity layer.
Structurally prevents them. How? Like, how can a merchant verify the bank's signature on a document if half the document is missing? Does not that break the math of the signature?
It would if you did it the normal way. But they use a cryptographic structure called a Merkle tree. Basically, every single field in the document, your name, the money limit, the time, gets turned into a random-looking string of numbers called a hash.
Oh, okay.
And the bank signs the very top of a tree made out of all those hashes.
So when the agent goes to the merchant, it does not give them your name. It just gives them the random hash that represents your name, along with the actual plain text of the grocery limit.
Exactly. The merchant can do the math to prove the grocery limit is part of the original tree the bank signed, but they have absolutely no way to turn the random hash back into your actual name. They are structurally locked out of the identity layer.
That is brilliant. But wait, I have to ask. Is this a zero-knowledge proof?
Wow.
Because it sounds exactly like one, and everybody in crypto loves talking about zero-knowledge proofs.
No, and I am so glad you asked that because this is a crucial distinction. It is not a zero-knowledge proof.
Really? Why not?
Selective disclosure is just redaction. It is like taking a black marker and blacking out fields on a paper form before you hand a copy to the bartender. You are still handing over a form.
Right.
A zero-knowledge proof is a mathematical guarantee where the form never leaves your pocket at all. You do not hand over redacted hashes, you just hand over a tiny math equation that proves a fact.
Oh, wow. So a zero-knowledge proof is way stronger.
It is, but this framework actively chose redaction instead of zero-knowledge proofs.
Why? Why compromise on that?
Because of computing power. Generating zero-knowledge proofs takes serious processing time. If you have millions of agents buying things at checkout counters, you cannot afford the latency of heavy math. Redaction via hashing takes milliseconds. It is a soft spot, sure, but it is a highly practical one for low-stakes things like buying groceries.
Okay, that totally tracks. Let us surface. We're coming back up from the ocean floor. And I want to bring this right back to the spine of the episode.
Please do.
The entire point of all that SDJWT structure, the redaction and the hashes, is simply that the permission travels as a small, sealed, self-checkable object. And it reveals only exactly what is needed.
Right. That checkable object is what allows the stranger on Friday to trust the human from Tuesday.
Okay, so now that the agent actually has this perfectly sealed permission object in its hand, it needs a road to drive on, right? It has to actually go spend the money.
Yes, it needs a payment rail.
And this brings us to Section 4, the Buy 402 rail. I find this part absolutely fascinating because of the history behind it.
Oh, the HTTP status code?
Yes. So the agent uses a payment rail on the XRP ledger, and it is called Buy 402. And that name is an inside joke for web developers.
Right, because everybody knows the error code 404. It means not found. You click a dead link, you get a 404.
Right. But HTTP status code 402 has literally meant payment required since 1997.
Since 1997.
Yes, the founders of the web built it into the very foundation of the internet. They knew we would eventually need a native way for servers to request a digital penny for a web page. But it sat completely unused for almost 30 years.
Because nobody could figure out how to send a single digital penny without a credit card company charging a 30-cent flat fee on top of it.
Exactly. The legacy rails made micropayments mathematically impossible. But now, with the XRP ledger, a transaction costs a fraction of a cent and settles in seconds.
So the 402 code finally has a rail to run on. A server can actually request a stablecoin payment mid-request, and the agent just pays it, without setting up an account and without needing an API key.
It is incredible. But let us talk about the specific integration that happened on July 22.
Right, the big event.
Yes. This is where MasterCard's verifiable intent framework, which they built with an infrastructure company called tfeed4.ai, actually meets a risk engine called Trustline.
Okay, so walk me through the mechanics of that. When the agent tries to buy the groceries, how does the system actually enforce the rules?
So the agent hands over the credential and the stablecoin payment. But before the payment clears, the credential goes to the Trustline risk engine.
Oh.
And the engine checks two things. First, it checks the bank's signature to make sure it is not forged. Second, it checks the bounds. Is it a grocery store? Yes. Is it $87? Yes. Is it day 3 of 7? Yes.
And if all those are true, the stablecoin drops onto the ledger and the merchant gets paid.
Right. But here's the most important mechanical detail. And this is a massive shift from traditional finance.
Okay, what happens if it is an electronics store?
Exactly. Let us say the agent gets hacked or glitches, and it tries to buy a $400 television at Best Buy.
It is outside the mandate.
It is way outside. So the risk engine sees the mismatch, and the payment is refused before it ever touches the ledger.
Wait, really? Before?
Yes. It is not a dispute filed after the fact. In the old system, the thief buys the TV, the payment clears, you notice it on your statement a week later, you call the bank, and a bunch of humans spend a month fighting over a chargeback.
Right, the merchant loses the TV, the bank eats a fee, it is a mess.
With Tier, it is blocked physically before settlement. The money never moves.
That is a completely different paradigm.
It really is. And there's one more detail about this Friday morning purchase. When that transaction happens, even when it works perfectly for the groceries, the user gets a push notification on their phone right end at 3 in the morning.
A little buzz on the nightstand.
Yeah. And I think that is brilliant. A system built entirely to remove humans from the loop still keeps them informed during the delegated act. You do not find out on the monthly statement. You get notified the second your intent is exercised.
Okay, so this specific way of doing things, granting permission by handing over a checkable object, it is actually part of a massive historical pattern in computing.
Is it?
Yeah. And I think naming the pattern is important. It is called a capability token.
A capability token. Okay, break that down for me.
Well, there are basically two ways to do access control in the world. The first way is what we're all used to. It is an access control list.
Like a guest list at a club.
Exactly. Is this like a VIP guest list at a club?
Yeah.
You walk up to the bouncer, you show your ID to prove who you are, and the bouncer checks the clipboard to see if your name is on it.
Right. Identity first, then permission.
Yes, but access control lists have a bottleneck. The bouncer has to hold the list, and if the bouncer loses the list, nobody gets in.
Okay, so what is the alternative?
The alternative is a capability. It is not a list. It is a physical door key.
Oh, I see.
Think about the lock on your front door. The lock has absolutely no idea who you are. It does not ask for your ID. It does not check a central database. It only checks one physical thing.
Does the key fit the ridges of the lock?
Exactly. If the key fits, the door opens. That is a capability token. The permission is baked into the object itself.
Okay, so verifiable intent, this whole MasterCard framework, it is just a capability token wearing payment network clothing.
That is exactly what it is. And we have to talk about the honest reality of this system because there is a serious trade-off happening here.
Yeah, let us talk about the trade-off, because on one hand you have the identity standard, ERC 8004, that's totally open to anyone.
Completely permissionless.
And the payment rail, by 402 on the XRP ledger, also completely open to anyone. You do not need a bank account to send a stablecoin.
But this new authorization layer, the mandate piece, is completely closed.
Totally closed. It requires a registered business. It requires a formal relationship with a card network like MasterCard.
Yeah.
You cannot just be some kid in a garage writing an agent and generating your own mandates on this framework.
Right. And we need to explain why that is. Why did this breakthrough come from the institutional side and not the open crypto side?
Well, it is about liability, is it not?
It is entirely about liability. Look, the hard problem here was never the cryptography. Hashing things into a Merkle tree is easy.
Right. We have had that math for decades.
The actually hard problem was who eats the loss when a boundary is crossed.
Because if a machine buys a TV instead of groceries, someone is out $400.
Exactly. And this framework rewrites decades-old dispute rules so that the operator of the agent takes the liability. If the agent goes rogue, the company running the agent pays for the TV.
Oh, wow.
And you cannot enforce that kind of legal liability on an anonymous crypto wallet. You need registered businesses and real legal contracts. That is why the institutions built it first.
That makes total sense. So we have built this whole machine piece by piece over this episode. I want to just quickly watch it run from end to end one more time just to solidify it.
Let us do it. Walk me through the full journey.
Okay, Tuesday. You click Approve on the mandate. Groceries, $80, 7 days. The bank signs it, hashes your identity, and hands a capability token to the agent.
Tuesday is done.
Friday arrives. The agent sees you need milk. It shows up at the merchant with its ERC 8004 identity. That answers question 1. Who is this?
Right.
It also brings its reputation history, proving it is a good buyer. That answers question 2, how has it behaved?
Okay, what about the purchase itself?
The server sends an HTTP 402 payment required message. The agent sends stablecoins over the Open by 402 rail.
And right beside that payment, it hands over the capability token.
Exactly. The trust line risk engine steps in, checks the signature, checks the bounds, and approves it before settlement. That answers the missing question, authorization.
And after the fact, anyone can check the mathematical proof that the agent ran its code properly, answering the final question of verification.
All 4 questions answered, executing in 3 seconds.
It really is a marvel, but it leaves some massive questions completely unresolved for the future.
Yeah, let us talk about the unresolved future, because this is not the end of the story.
Not at all. The first big issue is the centralization choke point. Does relying on traditional banks to issue these mandates just introduce centralization right back into a supposedly decentralized AI stack?
I mean, it kind of has to, right? If you need a bank account to get a mandate, then the banks are still the gatekeepers. It is a massive test of whether open layers with centralized services on top just inevitably converge back into traditional banking.
Right. Do we just end up reinventing Visa with extra steps?
Exactly. And speaking of Visa, that brings up the second issue, cross-network fragmentation.
Oh, yeah, this is a big one.
This whole verifiable intent framework only covers one card network right now, MasterCard.
So what happens when Visa builds theirs? Or what if someone builds one natively on Solana?
Right. An agent shopping across the internet would need a different permission slip for every single rail. It is going to heavily fragment the landscape unless they agree on a shared standard, which historically legacy networks hate doing.
So what is the main thing people should be watching for over the next year?
The appearance of a permissionless mandate registry.
A permissionless registry.
Yes. If the open source community can build a way to issue and verify these capability tokens without needing a bank to sign them, that changes everything.
But if they do not build one?
If one is not built, then the banks will quietly take the wheel of machine commerce right from the very beginning.
Well, that is a sobering thought to end on. But that was the why. The how is the rest of the show, and no background is needed. If you can follow a story, you can follow this.
Absolutely. And I want to leave you, the listener, with one final provocative thought to just, mull over on your own time.
Lay it on them.
If an AI agent can hold a capability token to spend your money, what happens when that agent decides to generate its own mandate?
Oh, wow.
Like, what if it wants to delegate a subtask to another, cheaper agent? Can a machine stretch its own intent across time and authorize another machine to act on its behalf?
Turtles all the way down.
Exactly. Just think about that. This is plain Strata, decentralized AI layer by layer.